Here we will see Task Parallel Library in C#. First we will see what is Task Parallel Library. The Task Parallel Library, that is TPL, is a powerful framework introduced in .NET that simplifies parallel and concurrent programming. It provides a set of APIs and patterns for creating and managing parallelism, which allows developers to write efficient and scalable code for multi-core processors and parallel computing scenarios. TPL primarily revolves around the concept of tasks, which are lightweight unit of work. Using the task parallel library, we can use the parallelism in the existing sequential code. That is, we can express the code as a parallel task, and these tasks can be executed concurrently, asynchronously, or in parallel depending on the requirement of the application. Tasks are designed to abstract low-level thread management and synchronization, which make it easier for developers to use the full potential of modern hardware without dealing with the complexity of the threads and locks. This library provides a set of classes that are used to manage parallel tasks as well as a set of thread-safe data structure. A key class of TPL is system.threading.tasks.parallel. This class supports a number of methods that allow user to iterate over a collection of data in a parallel fashion. This class supports two primary static methods as parallel.for and parallel.forEach. Then we see why is TPL required. First is performance optimization. With the increasing prevalence of multi-core processors, sequential code execution may not fully utilize available CPU resources. TPL enables developers to parallelize operations, improving application performance and responsiveness. Simplicity. TPL abstracts complex threading details, which make parallel and asynchronous programming more accessible. Developers can focus on the logic of their application rather than managing threads manually. Scalability. TPL scales well for both compute-bound and I/O-bound operations. It enables applications to efficiently handle concurrent tasks such as serving multiple client requests or processing large datasets. Responsive user interface. For applications with user interface, that is desktop or web apps, TPL helps to prevent UI freezes, which allows time-consuming tasks to run in the background without blocking the main thread. Now we will see advantages of TPL. First is simplicity. TPL simplifies parallel programming by abstracting the complexity of thread management and synchronization. Performance. TPL can significantly improve the performance of application by using multi-core processors. Maintainability. Parallel code written with TPL is often more readable and maintainable compared to low-level thread-based code. Resource management. TPL efficiently manages the system resources, which prevents thread and resource exhaustion. And cancellation and exception handling. TPL provides mechanism for task cancellation and exception handling, making code more robust. Disadvantages of TPLs are learning curve. Learning to use TPL effectively can be challenging for beginners, especially those who are new to parallel and asynchronous programming. Overhead. In some cases, there may be overhead associated with the creating and managing tasks, which can impact performance. Complex debugging. Debugging parallel code can be more complex as race conditions and concurrency issues may rise. Thread starvation. In scenarios with excessive parallelism, thread starvation or contention can occur, which affects performance.